Hello everyone, my name is Jiajie Zhang. I'm a third-year PhD student from Newcastle University. The submission number is 87. This paper is about a new approach to impact case study analytics. In 2014 Research Excellence Framework, the impact case study is introduced as an impact assessment of the researchers from UK universities in all disciplines. There have been several analyses of the impact case studies. Still, they have been either done through qualitative method or by using very basic forms of text mining. One of the most impressive works is from King's College London and Digital Science. This includes an online database for the impact case studies with the text search functions and APIs for filtering the document with text. They also carry out a report, which mainly use text mining approaches, such as topic modeling, keyword searching, and information extractions to visualize the data. Here are some examples of the figures in the report. From the word cloud, there are some keywords generated based on the term frequency in the details of impact section. Some keywords like work, policy, development, and health. And from the chord diagram, we can see how popular the topic is from the size of the colored blocks and the connections between the topics. They're good enough to form the themes of the researchers, but not good enough to review the context for further analysis. There are many other examples in the report using techniques like name entity recognitions and keyword in context, which aim to provide context for extracted keyword. But still, the underlying meanings of the terms remained unseen. So in this paper, we described an alternative approach, which the data from the impact case study is transferred into a structure format according to a specifically designed ontology. This captures the information in a form that also captures the context, so that it enables specific question to be answered through querying the structured data. Our goal is to support a wide range of questions and produce high-quality answers. The approach will be evaluated by constructing the knowledge graph and running the queries against it. At the beginning of this project, our driver is an interest in how to generate a high impact from the research project. We unpack this into questions about the route to impact, the quantifiable outcomes of impact, and underlying foundations that led to impact, such as publications, grant, and collaborations. This led us to design the list of the specific questions that we want to answer. To solve the problem, the first thing we will do is to find an appropriate representation of it. There are two main genres of the knowledge representation. One is symbolic, the other is connectionist. We still preferred the semantic representations, which is the symbolic, for several reasons. Despite the great success of distributional representation of natural language in deep learning, the deep neural network requires a large number of training sets, while the number of impact case studies is not enough to build the training sets for different tasks. Also, it is difficult to use the end-to-end models to explain the result. In this case, the entities highlighted in text will be extracted and represented in the forms of subject, predicate, object triples, conforming to the ontology. For symbolic representations like resource description framework and web ontology language, they give us a way to use the control vocabulary to describe both semantic and logical relationship between the entities in the real world. The advantage of using RDF is that the string in the text can be transformed into entities with identical URIs. For symbolic representation like resource description framework, the web ontology language, they give us the ways to use a control vocabulary to describe both semantic and logical relationship between the entities in the real world. The advantage of using RDF is that the strings in the text can be transferred into the entities with identical URIs. And by using the Sparkle endpoint services, we can easily query the data from external knowledge bases like DBpedia. The system makes it possible to carry out further analysis for impact case study and provide more accessibility for other researchers to integrate external resources and build the systems. Here is the general architecture of domain knowledge graph constructions based on our experience. As the impact case studies are mostly unstructured, to ensure both quality and accuracy, about 70% of the work will rely on manual extraction. Some natural language processing techniques such as name entity recognitions and entity linking will be used as auxiliary tools to reduce workload. Even though this looks like a left-to-right pipeline process, it is possible to make changes on schema when new predicates have been created or new data have been populated during the data acquisition process. This changes in the ontology often leads to the conflicts between the different versions of data, which will take lots of extra work during the development. So maintaining a reusable, stable schema is a crucial point during the iterative development of knowledge graph. We use predicates and taxonomy mainly from schema.org and Wikidata. These allow us to refer to a standard vocabulary without reinventing the wheel. We design some of the key relations and properties do not have the equivalent accordingly. We started as a top-down construction with a focus on a few key elements like organization, fundings, collaboration, and output. After several iterations, we created a knowledge graph with 8,000 entities and 51,000 edges. Some extra information from company, house, and EPSRC grant database were extracted by web crawlers. With the aligned entities, we can also use Sparkle endpoint to query the knowledge bases like DBpedia, Jiajie, and Wikidata. So let's have a look at the visualization of the ontology. There are some of the key elements in our ontology, such as organizations, activities, research output. Both of activities and research output class has a long list of the subclasses. We can only show the parts of them on the left. Then we will talk about some of the natural language processing tools we use in the project. The name entity recognition is a famous subtask of the information retrieval. It aims to extract entities like location, organization, person, times, and numbers. The NER method have evolved a lot from the early days technology like dictionary-based extraction. The best solution of NER has achieved more than 92% of accuracy based on deep learning method recently. So we mainly use tools like spaCy to extract entities and its context sentences. And here is the result of the name entity recognition using spaCy. The extracted entities without referring to actual entities are only meaningless tokens. In the real-world cases, there are many entities that share the same names, so the process of entity linking is to help disambiguate the entities in their context sentences. It can also be used between the structured data, such as knowledge fusion between different knowledge graphs. In this task, some of the useful tools like spaCy entity linking and fast entity linking will be used to produce the links to the knowledge bases. Then we will manually check those linked entities afterwards. Relation extraction is the most challenging part currently. Most of the recent research are focused on open domain relation extractions using deep learning. However, deep learning based methods often requires enormous labels for training. its performance will drop dramatically when the domain changes. Since our project is a domain specific and has a high demand on the quality, we decided to use manual extractions only in this task. So let's move on to next. Most of the data properties like date, time, amount, currency, names, they're already in the list of the vocabulary in schema.org. Some of the data properties we're interested in, like the amount of people affected and the company status, are designed specifically. After all this effort, we will be able to construct a graph based on a single case study. Looks like this. The graph tells us that the Newcastle University has several collaborations with the spin-off company eTherapeutics and the research output produced by the collaboration. Other information like the grant detail, patent, and published paper were captured as the graph structures. Here is the list of the predefined questions we want to answer with our structured data. We combined them into one query to prove the Sparkle's ability in handling complex queries. This answer shows how IBM is involved in the impact case study, as we see different types of activities in the list, and the numbers after each of the activities indicates the case study context. In this example, the Sparkle query can simply handle the operations like aggregations. In this query, we expand the details of grant from EPSRC. Some of the data were crawled from the EPSRC website, because not all of the case study provide the amount of funding they received in the text. This is one of the key factors we believe that generate the impact in the case study. This query is just to show a list of the open source application released from the impact case study. For further analysis, we can also ask questions like which company has used these applications. As we've already seen from the graph example above, the details of the granted patent and the patent application are also the key factor for generating the impact. We can also use the link to the patent entity to find out which product or technology has been given a patent. And all of the patent entities were linked to the Google patent site for further analysis. So let's move on next. So there are many spin-off companies in the impact case study. In this query, we can see which spin-off company was acquired and the amount of money used for the acquisition. As you can see, some of the amount is unknown here, so I used the option here. The last question, I used the Sparkle query to retrieve the number of the companies inside and outside the UK. Then we can see the list of the company. Similarly, we can use external knowledge bases to query the company's netcom, revenue, number of staff, services they provide, etc. As long as they are available in knowledge bases, they can be used to describe the entities. There are many ways to explore those interesting facts when we query against the knowledge graph. For example, using different types of activities or publication-related data. For answering the predefined questions, it has already gave us the accurate result with enough context. So this is the first part of our project. We're now using the knowledge graph as a basis for applying machine learning to extract interesting patterns from the data and to see if the grade awarded to the case studies can be accurately predicted. And that's all for today's talk. Thanks for watching.